Hello friends, welcome. Friends, satellite communication has become the talk of the day. Why? Because of the recent announcement between Bharti and Starlink and Reliance Jio and Starlink of them collaborating with each other and offering satellite services to Indian consumers. Now, because of this, there have been a lot of speculation that what kind of advantage that Indians can leverage through this partnership. Now, because satellite as a subject matter is quite nuanced and complex, and I have done multiple videos and articles on this topic, I thought of anchoring all those discussions in a most simplest form possible so that the layman can understand, and I have created a slide deck so as to make this discussion more efficient. And if viewers have any confusion and question, they can pause the video and look at the slide, which will tell its own story. You can basically look at the slide as because these slides are standalone and will be able to explain all your queries. And if you are not able to understand what I'm talking about. Now, the title of this presentation is Satellite versus Terrestrial Network, Complementary or Competitive. Okay. And then what I've done is I have created a slide, an opening slide, which talks about the key questions that we are going to investigate in this presentation. So the first question is, why do satellite use high frequency band for broadband and low frequency bands for mobile integration? Many of the viewers may not even know this fact. But this is the fact and we are going to investigate. Second fact is, why are satellite terminals significantly more expensive than mobile and FWA device, which is fixed wireless device using terrestrial network? Why can't satellite service pricing compete with terrestrial network pricing? If satellite mobile networks share the same spectrum, why must they operate in different geography? Now, why should they share the same spectrum? Because they need to offer services in a commercial mobile phone, which are currently operating in the IMT band. So you can't expect a satellite to operate in a separate frequency band and integrate on mobile devices, because then the mobile devices have to be reconfigured to support those satellite spectrum band. Why is satellite broadband unaffordable for most Indian consumer, and why are the most IMT spectrum bands in India in the low frequency are unsuitable for supporting satellite mobile integration? Okay, so let's go to the next slide. So first, let's understand the architecture, because without understanding the architecture, we can't really understand what is going on. So you can see different services, different delivery approach. Satellite is a different service, and I'll explain to you why it is a different services. It is not the same service, and that is why it has got a different delivery approach. Though you can use satellite for internet, but fundamentally the service is quite different. Okay, so let's explain first the architecture. Terrestrial network is here. So where you have these terrestrial BTSs, everybody knows who are following telecommunication. Even if you are not following telecommunication, you know what tower is. And everybody talks about the tower nahi mil raha hai, the signal is not coming. So you know that, tower is where you get the signal, and the size of the radius of the coverage is pretty small. In case of satellite, this coverage is pretty large because satellite is up in the sky and these are ground-based base station. And what you do is that you make the coverage small in order to able for you to put multiple towers. Whereas you don't have the luxury to put multiple satellites on the sky because there is a limitation. The number of satellites cannot grow exponentially large, and that's why the footprint is much larger than terrestrial network. This is fact number one, and therefore the terrestrial networks are designed for high population density and satellites are designed for low population density, because the bandwidth that you have, the spectrum that you have is not going to be unlimited, and here you have the capability to use the same bandwidth in different geography, multiple times the number of towers that you place. Whereas in case of satellites, the number of satellites are limited, therefore you can't multiply the bandwidth because of this larger footprint. Okay, now let's talk about the next chart. The next chart is just an analogy. Why I am using this analogy? For those laymen who do not have an understanding of this, and be with me, you will understand. So I have created a terrestrial network and I am representing a base station coverage by a pond size. So there is a pond number 1, pond number 2, pond number 3, 4, 5, 6 and so on in a geography of population, let's say 1000. Now in a satellite, this is the same geography of 1000 population, but the pond size, pond is only 1. Now, why I'm showing a smaller pond here? Because pond is the representation of bandwidth. the amount of bandwidth you have. So here you have the same bandwidth repeated in different areas, and people who are living in the close vicinity of this pond will be able to take water from this pond. Whereas in case of satellite network, there is no luxury. All the people, all the 1,000 people have to share from the same pond. Now you get the analogy. That's why the satellite network cannot serve in higher density population area. They have to serve in a lower density population area. Okay. Now spectrum utilization, low versus high frequency band. Now the terrestrial networks typically uses low frequency band, satellite uses high frequency band. I'll explain the reason why, right? Just be with me. In case of low frequency band, the coverage can be higher of the base station and the penetration of indoor is possible, and you need indoor penetration in case of terrestrial network, whereas in case of satellite network, indoor penetration anyway is not possible, and because of certain requirements, the satellite have to use high frequency band, and if they can't use low frequency band, they can only use low frequency band for mobile interconnection where there is no possibility of them to use high frequency band. I'll explain that. In case of terrestrial network, frequency review is possible, but in case of satellite network, because they are using high frequency band, they have another leverage, right? Which the terrestrial operators also have, but high frequency band will make the number of towers go so high, therefore, there is no point in using high frequency band. Just that is why you see 26 gigahertz band in India is lying vacant and nobody is using it, right? But the satellite frequencies are within that range. So what they do is they use the technology of beam splitting, means they are able to set multiple beams within the same footprint, right? And able to drive more capacity. You understand what I'm trying to talk about? It's like for example, let's say if you have an optical fiber cable where multiple fiber strands are running. If you have only one strand, then the capacity is N. Now, let's say if you have M number of strands, then you multiplied M with N, the capacity increases. Similarly, beam splitting, which is a phenomena which is very efficient for high frequency, can be leveraged by satellite network, and that is the way they can raise their capacity by using beam splitting, which is not possible in case of low frequency band. Otherwise, what will happen? The satellites will become so unwieldy because of the antenna sizes are going to become so large, because you need to have multiple antennas to be able to support beam splitting, making the whole network configuration unfeasible. And then satellite has to share the same spectrum band among different operators. That makes it more challenging. Why can't the separate operators have separate blocks of spectrum? Because there are not sufficient spectrum available, because you need a very large chunk of spectrum, 1 gigahertz. Right? You can't basically operate with 100 megahertz chunk, because if you are going to segment the spectrum in smaller chunks, then the overall throughput is going to become very, very low, and satellite is very inefficient from the point of view of using spectrum capacity, because the number of satellites are limited and frequency use is not possible. That's why sharing becomes a necessity. Okay. Whereas in case of terrestrial, it is an exclusive use, and therefore the operators have the full capability to use spectrum as efficiently as possible, and the network configuration is fully under the control of the terrestrial operator. Okay. Now let's go to the next slide. Satellite networks, why high frequency band for broadband and low frequency band for mobile? This is a question that we need to answer, and I told you I'll answer this question in this presentation. Now what happens is that in case of low frequency band, the quantum of bandwidth is pretty limited. As I told you that low frequency band, let's say 900 megahertz, 800 megahertz, 2100 megahertz, you have capacity in 20 megahertz, 30 megahertz. Whereas if you go to high frequency band, you have got large quantum of spectrum, 1 gigahertz, 1.5 gigahertz, etc. And since you have limited number of satellite, you need very large quantum of spectrum to have high throughput, and you need beam splitting capability. Otherwise, you cannot basically enhance the spectrum and the throughput significantly. And that is why satellites are using high frequency band for mobile broadband, whereas, for broadband, a fixed broadband, whereas for mobile integration, they have to use low frequency band, which I'm going to explain in the next slide. Why? They use low frequency band for mobile integration. Now look at this chart. This is the explanation chart. This is a very narrow RF beam. And why this is narrow? Because this is a high frequency wave. and this is a low frequency wave where the both are being emanated by a satellite. Now what happens is that when you are having high frequency RF wave, your beams are very narrow in nature. So if you have, let's say, a fixed wireless terminal on the top of your rooftop, it is very easy to manage and track satellite because you can have those beam steering capability inbuilt into those devices, and you can track those satellites because those FWAs are a little bigger in nature, whereas the commercial mobiles are very small form factor. So if you are going to use very high frequency band, you will never be able to track those mobiles, or the satellites cannot be trackable by those mobiles because these satellites are moving at high speed. Now, in case of a low frequency band, the beams are quite wider, and that makes the mobile easy to track these high frequency, high speed satellites moving in the Earth orbit in a very, very fast manner, right? Now let's look at the device costs and capability, right? Terrestrial versus satellite network. Now in case of terrestrial network, because the network is very, very close to the device, and that's why the device and the volumes are pretty large. You can see the world is full of terrestrial devices. Satellites are hardly millions, right? So you can have a benefit of economies of scale that makes the device cost cheaper because the complexity of the devices are much, much less compared to satellite devices, where the distance between the mobile and the satellites is pretty huge, and therefore you need to manage the connectivity between mobile and satellite with utmost dexterity. You need to do that, and that makes those device costs are extremely costly and pricey. So, and then we have the low data transmission on comparable bandwidth. Now what happens is that when you are using low bit rate, for example, in case, let's say, this point is very, very important, right? Now let's say if you are in a terrestrial network, right, and you want to transmit high speed signal to your mobile, right? So what you will do, because there is a distance, let me just show you exactly how the situation is, and then only you will understand this particular point. So you have a terrestrial network, right? And you will have a mobile here, right? Sitting here, and it is talking to the base station. Now the mobile and the base stations are quite near to each other. Now this distance can be in kilometers. So, or maybe in meters. So let's say if your mobile transmits to the base station and base station is has not received the signal because of distortion in the middle of the transmission, it can request retransmission. And the cost of retransmission is not going to be that large because the distance is very low. Whereas in case of satellite, this can be hundreds of kilometers. So let's say if there is a mobile here and it has not received the signal and it is asking for retransmission from the satellite, or the satellite is asking retransmission from the mobile, this will make the cost of retransmission very, very high and making the network very, very inefficient. And that is why in case of satellites, the bit rate that is used conventionally, if you compare apples to apple, is of a lower QAM compared to conventional mobile, because you can't afford to lose signal. And that's why the satellite networks have lower spectrum efficiency compared to terrestrial network. Now let's look at, is satellite broadband affordable for average Indian consumer? This is a very, very important analysis which I had done in one of my articles. I'm going to share the link in the description, which is based on the economic analysis for data which has been provided by the Ministry of Statistics and Program Implementation. So what they do a survey of household consumption expenditure. So this block that you see here, it's basically a identification of the various buckets of item which a ordinary consumer, on an average consumer, will spend. How much percentage if he is spending 100 rupees. You got it? So it's almost like the CPI weights. And by the way, this household consumption expenditure survey is used as a reference to calculate weights, the CPI weights. Okay. So here, if you look at all these items, you will find that consumer service and excluding conveyance is the only item which can anchor the expenditure on communication. So this for urban area is 5.72, right? Means 100 rupees if you spend, you will spend 5.72 on communication services. Because of that, and if you do go through my article, this is a little complicated to explain to here, is that what I have done, let me just make an attempt, because otherwise those viewers who are not interested in going to the article may be able to understand what is going on. So what I've done here is that I'm estimating the absolute consumer spend on communication circle wise, and trying to get some insights. So these are circles, right? This is, I told you that for urban area it is 5.72. For rural area this number is 5.25. And what I've done, because I have got the pan India integrated number, as well as they give us a breakup of the numbers on a state basis, which I have mapped to the circle. So because I know these numbers, I have been able to calculate individually for each and every circle for rural and urban areas for this spend on communication, right? And then what I have done is, since I have had another information of the fractile classes on a pan India basis, means how much population is having what kind of expenditure capability. For example, 0 to 5% population has got an expenditure capability of 1677. Pan India this number is, rural is 4122. For urban it is 2376. Pan India is 6996, right? Because I know this, so what I have done, I will be able to calculate the ratio. Means this divided by this is going to give us the ratio. On the basis of that, I have further divided this 216 and 400, which you find here, into this category. And on the basis of that, I have created this matrix here, which for the urban area maps out how much an individual would be spending based on the category of or the fractile classes of the population for this for communication. And you will find that 95 to 100% population, there is a respectable spend. But in this area of the chart, the spending is pretty low. You can pause the video and have a look at it, which kind of gives us a very clear understanding that very few people in India will be able to afford satellite broadband, because it's a very pricey service. If you recall, initially they were priced at $99, which is 9,000 rupees per month. So you can't afford, right? That is the reason. So in nutshell, what it means, only a small fraction of Indian population can afford high-cost satellite terminals, which are very expensive service plan. Now, what about mobile handset integration? We have already spoken about it briefly, and in this video, I plan to give you a little bit more deeper dive. Now, the current regulatory deliberation which is going on, which is currently being debated by TRAI, where the TRAI has not come out with the recommendation, talks about the assignment of these spectrum bands for satellite services. Now, as I told you, high frequency satellite spectrum can't be integrated on commercial mobile devices, and therefore the current bands are not possible to get integrated into mobile devices. So there is no question of the current spectrum being used for mobile device integration, which is very clear. Now what happens is that how can satellite can be integrated on mobile device? Because the next phase of discussion would be mobile level integration, which can scale. There could be some volumes. So you have got two options. Option one, you can have IMT spectrum, the existing IMT spectrum like the 800, 900, 700, 2100 and 1800 megahertz spectrum, but you can't use 2300, you can't use 2500, you can't use, because those are TDD spectrum. You can't use satellite. Broadband does not work on TDD spectrum. It needs only FDD spectrum. And there is another article which I have done on this. I am going to paste the link of the article in the description. There is another option, is that you use low frequency spectrum band, which are not IMT based spectrum, but like for example the Global Star L band, right? So both options are possible. The problem is that in case of the advantage of option one is that the commercial mobile device are already having the capability of IMT spectrum, whereas in case of option two, you need to build that capability, and depending upon the volumes, the device manufacturer will choose to do so, right? So what are the challenges that integration of satellite with mobile network, right? The first and biggest challenge is RS signal interference. And that's why both the networks must be physically separated. They can't be integrated to work seamlessly in one single geography. And then there has to be a spectrum coordination. Means the mobile operator leasing their IMT spectrum to satellite provider must closely coordinate to prevent interference. I am going to explain to you with using a diagram. There has to be seamless handover between terrestrial and satellite network, and 3GPP is currently working on developing a standard to enable the seamless handover. And there could be transmission overspill between a mobile operator spectrum, which is different for every circle in India, because there is circle-based license India gives, that will create a possibility of spillover into a neighboring operator spectrum band if one has tied up with a satellite player using their existing IMT spectrum. And let me explain what I mean by this. why satellite and mobile RF signals are incompatible. This is the diagram which explains. You have got satellite and you have got different base station which is sharing the footprint of satellite network. Let's say if this is the case. Now you have a mobile network which is receiving signal from satellite and from the terrestrial network. Now, since these two signals are traveling different distances, one is in maybe in kilometers, another is with thousands of kilometers, hundreds of kilometers, so there will be incompatibility at the point of integration. And so this device have to wait for the signals to get received from the satellite, right, before they receive it from the terrestrial network. That will lead to inefficiency. So there will be a lot of inefficient use of spectrum, and that is why the satellites and mobile satellites do not seamlessly integrate with mobile networks, even though the frame may be of similar nature, because of this signals traveling in different distances, and therefore overlapping terrestrial on the terrestrial coverage working in the same spectrum block is not possible, right? Let's go to the next slide. So, India's specific challenges in satellite communication. Spectrum fragmentation across various circles. India's circle-based frequency assignment lead to heterogeneity across state border boundaries. Limited value of satellite network for mobile user within near ubiquitous, because we have got near ubiquitous coverage. What is we are going to do with the satellite network? Somebody going to Mount Everest or some other desert may be able to use their mobile coverage, but those are going to be affluent customers. There will be spectrum sharing constraint, right, which we have already talked about, and satellite connectivity is viable only for fixed terminal use, which we have already seen. And this is the summary slide, the key takeaway versus satellite versus terrestrial network: coverage, spectrum utilization, device cost, performance speeds, affordability in India, challenge in integration. And you can, you can pause the video and you can have a look at this. Okay, and just and the last point, because we already overshot 20 minutes of my video, I'm going to show you, for those viewers who have not seen my earlier video, which kind of gives you an indication of heterogeneity. So this is a YouTube video which I have uploaded in YouTube. So I'm going to run this. This is for 900 megahertz spectrum band, and you can see the border interference. So when I run this, you can see that this is basically every color denotes a different operator holding the same frequency block. Now you can keep on see the colors are keeping on changing. So these boundaries, right? If you are operating a satellite spectrum band, this boundary management, the state boundary management is going to become extremely difficult. So that is why, unless you have a pan-India spectrum assignment strategy for low frequency band, it becomes extremely difficult for satellite mobile integration using our existing IMT spectrum. 22 minutes have passed, friends, and I have tried to, zip the whole thing in a very short window period of time. And I hope that you probably have understood what is in for India, what kind of challenges and what kind of opportunities exist. And I hope that you like this video. And if you have any question, you can send me a direct message on the comment section, and I'll try to answer that question. And many thanks for listening till the end, and I'll come back with a new video next time. Thank you very much.